Hello everybody. So today we have a problem here for you. A coolant fluid flows steadily through a rough horizontal circular pipe that is 30 feet long and has 0.12 inches in diameter. The pipe has a relative roughness of 0.005. The coolant has a density of 1.93 and a dynamic viscosity of 3.326 times 10 to the negative fifth. The pressure drop across the pipe is measured to be 6,474. You are given an equation for the pressure drop, and your goal is to find the friction factor, and you only need to do 3 iterations. So, from it telling you only need to do 3 iterations, you kind of can guess that this is a iterative solving a problem. But you can also gather that from the fact that in order to find friction factor, one of the key components within that is the Reynolds number. And because then you use the chart, obviously, and yeah, you already know how to do that. But in order to use the Reynolds number, you need the velocity. And all throughout this problem, the velocity is not given. So what is given is the pressure drop equation. And it has velocity there. But as you notice, there's this F here, which is the friction factor. So there is quite the predicament here. So the very first thing to do is to rearrange the equation in terms of this velocity. And as you can notice that the friction factor is still in there, but it's not really that big of a deal because the way that we will attempt this problem is through kind of like a guess and check. So we have all of our values written out right here, and units are really important because as you can see, the diameter was given to us as 0.12 inches, but for consistency and for the equations to actually work, all of the units have to kind of align with each other, or in terms of this is feet, this is feet, this is feet. You can't have this be inches, so you need to convert it to feet. Very easy mistake to make. When I was first solving this problem, I realized I was getting weird numbers, and then I took a look back and I forgot to convert to feet. So the very first way to test this is you create a guess for your friction factor number. So I usually start with about 0.02. I think that's a fair ballpark. It doesn't really matter as long as it is a realistic number. You should not start with, for example, 1,000. Obviously, that would not work. So what you do with that 0.02 is you plug this 0.02 into the friction factor there, along with all of these values also there, and that gives you velocity. What you can do with that velocity is get a Reynolds number, and that's extremely important because you find this Reynolds number, and then you can use this equation called the Colebrook equation. And that is, I shall write it down here, 1 over the square root of the friction factor is equal to -2 times log base 10. This is the relative roughness, 3.7, 2.51 over the Reynolds number times the square root of the friction factor. And what you can do with this is use a graphing calculator, or for example, Desmos, and iterate the friction factor itself, given the Reynolds number inputted right there. And so the way this kind of works is, for example, we solved for the velocity when testing this random friction factor that we set up. We got a velocity of 10.57. Then we found that the Reynolds number with this velocity is 6135. And so the way this works is you use the 6135, you plug it in there, and then you use your graphing calculator or Desmos to solve. And I can show you right here. So this is an example of Desmos. And I actually was using this to solve it. 61 or 6125. And so the way I set this up is I put it technically like equal to 0. Oops. Yeah, sorry, 0 equals. But in Desmos, you don't need to do that. On your graphing calculator, obviously you do. And Desmos is really nice for especially homework because it kind of gives you an automatic zero finder. With whatever calculator you have, I know TI-84s plus CEs, you're able to use the second trace, and there's like a zeros finder for the graph. But whatever calculator you have, make sure you can look it up and be prepared for the exam. But on Desmos, if you just kind of zoom in to where the 0 on the axis is, there should be a little gray dot, which you can click, and it'll tell you. So it's 0.040929. And so yeah, 0.0409, I think when I was iterating, I did the full value. Obviously, you should use as many decimals and numbers as you can when solving so that you don't have propagated errors. But with this friction factor, then what you do is you use this as your next guess. So you go all the way back to your velocity equation here. You use these same constant values, but this friction factor is now going to be 0.04091. And then it's pretty much the same process where you use that to find the velocity of the second test, which, as you can see, it went down a considerable amount, so now it's 7.39. Then that will give you a new Reynolds number. Once again, it's the same formula right here, the regular Reynolds number formula. And it's the same exact process. You take this Reynolds number, 4290.247, and you plug it once again into the Colebrook equation, and same thing with Desmos. So we can go here. That number was 4290.247. So okay, perfect. So yeah, as you can see, once again, it hits the 0, and now it's 0.044023. And just in case it wasn't clear enough, this Reynolds number, you just change the Reynolds number right there on the Colebrook, because everything else is the same. Your relative roughness is the same, and obviously your variables are the F's. That's what you're looking for. You're looking for the new friction factor. So then, as the problem stated, that you only need to do 3 iterations, which usually should be the standard also for homeworks and exams, unless otherwise specified. You take this number once again, you plug it into your velocity equation here, especially right there. You use the same values. That spits out a velocity for you right here, 7.11. This is a good sign because, as you can see, we started out at 10, got down to 7.39, and now 7.11. The difference between this and this is really, really close compared to, 10.5 and 7.3. The more and more that you do this, these like iterations, these tests, it should theoretically converge, and there should be almost no difference, or at least very minuscule difference. And you can prove that using like a percent difference calculator, and that potentially could be a way of, instead of saying, oh, only do 3 iterations, it could ask you, prove that there's only 1% difference between iterations. And that's simple. You just keep going until the percent difference is this and this, and you can Google that formula and be prepared for that. But yeah, so once you get this velocity, you get the Reynolds number corresponding. You plug it back into the Colebrook equation, and you get a final value of 0.0444. Awesome. Thank you so much. If you have any questions, please feel free to leave a comment. Thank you.